chemistry, we have some naming practice to go over because y'all have a quiz coming up soon. Again, the quiz is just on naming, alright? I'm trying to get in a couple of small, medium-sized grades in before the end of the marking period. We have a little while, right? We have the week before Thanksgiving, the 2 days before Thanksgiving, and the week after Thanksgiving, which is really only a 4-day week, but it's a good amount of time. So we have some stuff to do. I want to cover some ground, but let's talk about this naming. I wanted you to not only name stuff, but also identify, is it ionic or is it covalent, right? Because in order to actually name something, you need to know whether it's ionic or covalent so that you know which set of rules to use in order to name it. So I will do that bit first, the identification first, and then we'll go over in between, or into each one of them, and see how to name them. First one, number one, is covalent, because it's only nonmetals. The second one was ionic. It has a metal, which is something from the left side of the periodic table, and something from the right side. It also has a polyatomic ion, so you know it's ionic. Number three was covalent, again, all nonmetals, everything on the right side of the periodic table, or hydrogen, right? Remember that hydrogen is a nonmetal. Number four was ionic, because you have a metal and a nonmetal. Alternatively, you have a polyatomic ion. Number five is ionic, silver is a metal. Number six was covalent, I and O are both on the right side of that table. Number seven was ionic, V is a metal. 8 is also ionic, Pb, again, a metal. 9 was covalent, C is definitely a nonmetal. H, again, we said hydrogen. It's on the right side of the periodic table, but it is a nonmetal because it's a gas, so we don't consider it metallic in any way. And finally, number 10, also covalent. So now that I know which rules I'm using for each one, I can go ahead and create the name for these compounds. The first one that we have is going to be boron tribromide. And the reason for that is we have prefixes for covalent compounds. We always write the prefix unless the first element is 1, in which case we ignore the mono because it just becomes wordy, right? It becomes a little much. There's no reason for that. So it's not monoboron tribromide, it's just boron tribromide. Alright, the second one was ionic, which means the first part, the metal, is going to keep its name. It's going to be calcium. The second part will be sulfate, because SO4 is a special combination of elements. It's a polyatomic ion, so it acts as a group, and we have to keep its name all together. Remember, they're all found on table E of your reference table. The actual combination of elements, the charge is in the top right, and the name is next to it on the list. Just be cautious when you're looking at that list because there are a lot of polyatomic ions that look similar. So like SO4 is sulfate, but SO3 is sulfite. So just watch yourself there, alright? Alright, number 3, we're back to our covalent rules. So we have dicarbon, hexabromide. Right, dicarbon because there are 2 carbons, right? Hexabromide because there are 6 bromines. I quite like the covalent ones because in my opinion they're much easier to name. It just, you have the number, that's your prefix, and you don't have to worry about looking for charge, you don't have to worry about table E. It's just, you see a number, that's the prefix you use. Soon, number 9, right? Well, number 9 down there. We'll talk about the one weird prefix, right? So we have another ionic one. Cr is chromium. I know that I'm going to need parentheses because if I checked the periodic table for chromium, there's more than one possible charge. CO3 is the polyatomic ion carbonate. Now CO3 has a charge of -2, but there are 3 of them. So my total negative charge is actually -6, which means this chromium is a positive 6. It has to be a positive 6 charge. That, again, that is as high as the positive number will get. I've never seen a 7, 8, 9, or a 10. And even the 6 comes up infrequently. But be really careful trying to come up with the charge for that positive ion. Remember, use the negative ion to determine what the positive charge will be. We're going to do a similar thing in number 5. This is silver phosphide. I guess I shouldn't have said we're doing a similar thing in number 5 because, well, you do a similar thing. You look for Ag, you find that the name is silver, and then check that top corner, right, of the box. Silver only has one possible charge. It can only ever be +1. And because of that, it doesn't need the parentheses. It doesn't need the clarification. In the same way for number 2, we didn't need a clarification for calcium. It can only ever be +2. So that parentheses for naming ionic compounds is only ever going to come up when you have to clarify on a charge. We're back to covalent rules for number 6. So we have iodine dioxide. Not monoiodine, it's just iodine dioxide. Now number 7, like, have an asterisk. This is a bad example. And I apologize for this one. I should have vetted this better. The reason this was bad is not because of the first part. The first part is vanadium. I know I need a parentheses. The weird part was right here. And now you might have just said oxide because you saw the O and you're like, well, every time I've seen O, it's just oxide. O2, it's a bad example because O2 is a poly. And it's very odd. It's very specific. It comes up hugely infrequently, right? And the reason it's bad is because O2 is a poly with a charge of -2. Which means that in the parentheses, I need a +2. But if you just check the periodic table and you went to oxygen, you would find that it has a charge of -2, which would mean that 2 oxygens at -2 is a negative charge of -4. So you might have had vanadium 4 oxide. And there's no way of knowing that unless you went out of your way to look onto table E for the polyatomic ions, which you have no reason to do right now. O2 looks like just a normal thing, right? Number 7 is a bad example, and I'm going to refrain from using examples like that kind of as we go through here because it's really not very promising, not very good. It's not indicative of the kind of things that you will see. And I just undid something and I don't know what I undid. Oh, wait, I do know what I did. Hang on. Sorry. What I wanted to do was this. So it's supposed to be vanadium 2 peroxide. I'm not going to ask a question like that. I'm not going to find a question like that. I'm not going to go out of my way to trick you. That was poor. It was a bad example. And again, I apologize for not looking at this better. Ms. Summers and I have talked about this. We're going to remove that example from the notes for next year because peroxide just doesn't come up often enough to warrant using it as a naming example. Sorry, kids. Number 8, we are back to ionic naming and PBS. So not like the TV channel, but it's lead something sulfide. Again, that IDE ending because it is only S, right? It's not SO4 like before. So lead could be +2 or +4. If I check sulfur, which is what I get the sulfide name from, and I look for the negative charge that it could have, it can only ever be -2. So lead is going to be a +2. Right? We're finally down to 9 and 10. These are both covalent, which means they're both going to be prefixes, right? Prefixes only ever exist in covalent compounds, or molecular ones, right? You're not going to see them for ionic. Now I'm going to ignore the 1. I'm just going to... Hello? Yeah, there we go. It's going to be carbon. And remember, our prefix for was tetra, like Tetris. carbon tetrahydride for number 9. 1 carbon, 4 hydrogens. And then number 10 is going to be dihydrogen trioxide for 2. Oh, that's not that. No, it's not going to be dihydrogen trioxide. A little bit of a smooth brain moment. Reading is hard. Let's try again. Dinitrogen trioxide. There we go. That's correct. Right. So it's 2 nitrogens, 3 oxygens. Because that's what the numbers say. It's the subscripts say. So the prefixes are going to follow the numbers. Now, there are many examples still that we haven't quite completed. I'm just going to zoom out for a second here to show you. There are still these questions here at the bottom of 25 and top of 26 as far as going from a name to the compound. That's all ionic practice. Right? We also have a little bit more mixed practice, right? So you see tetraphosphorus triselenide. That is an example of a covalent name that you can turn back into a compound. Then there's potassium acetate, right? No prefix means that this is going to be an ionic name that you can turn back into a compound, right? So you have bottom of 25, top of 26, bottom of 27. If you actually go a little further into the notes, skipping over chemical equations, which we'll start talking about end of next week, there's actually even more naming practice down here on 31 and into 32. Again, mixed naming, right? You have both ionic and covalent compounds. I can tell that this number 1 here is ionic because I know that Na is a metal. It's on the left side of the periodic table. Br is a non-metal. I know that number 3 is covalent because both P and O, phosphorus and oxygen, are both nonmetals. So there's still even more examples, right? The solutions for the examples will go up in the notes, so the notes will be replaced by a more updated version of them. It will go all the way out to page 32, just purely to include these 2 completed sections, alright? If they're not up right at the time this video is posted, keep checking periodically, because it just may take some time to upload. If you really can't find them and you're desperate to find them, send me a quick email and I will very gladly give you the answers to whatever you need if you're checking yourself. But this is your practice, right? You don't have any official remote work other than to study for this quiz. Make sure that you know how to name an ionic compound, how to name a covalent compound, and how to go backwards, right? From the name of an ionic or from the name of a covalent compound, be able to go backwards and create the formula. That's all the quiz is going to be on. It's 10 questions on that, all right? So be prepared, be ready for that. After the quiz, there will be a virtual lab that will go up. So in a similar way that you did the last one, it's also going to be on naming. You'll get your tests back in the very near future. So the 5 questions that you skipped on the test will also be another homework assignment. And I'll talk about that probably when I talk about, like on the quiz day, there'll be a video that just goes up explaining like, hey, this is what I'd like you to do. And yeah, that's pretty much it for before the quiz. All right, so make sure that you're studying, make sure you're prepared for this. If you do have questions, send me an email. You can check yourself with all this practice, any of this practice. Yeah, all right. I will see y'all soon enough. All right, in the meantime, be good, stay sane, take care of yourselves.